What's up, everybody? It's Chris Shabbat, and I'm back with another Chem 1B video. Today we're going to do the Clausius Clapeyron equation. I don't know if I pronounced it correctly, but I promise you can get these problems right without knowing how to pronounce it. So example problem 1. The vapor pressure of water is 1 atm at 373 Kelvin, and the enthalpy of vaporization is 40.7 kilojoules over moles. Estimate the vapor pressure at a temperature of 363 Kelvin. So like most of the problems, we actually do have an equation. So our equation is as follows. ln P1 over P2 equals delta H over R, which is a constant, 1 over temperature 2 minus 1 over temperature 1. Now, these are two pressures over here on the left. These are two temperatures. Our R is equivalent to 8.315 joules per mole Kelvin. Okay. And then delta H will always be in joules per mole. Okay, so let's jump into this problem. So it gives us this piece of information right here, which I'll call 1, or actually I'll call it 2, and I'll explain why. So this will be our second set. So over here we have our P2 and our T2. And over here we have our T1. Here we have our delta H. And of course we have R, so the only variable we're missing here is P1 now. So let's just plug in. We have ln, again, P1 over 1. And that's equivalent to, now, our constant says we need to work with joules, but our problem gave us kilojoules. So that means we have to actually convert kilojoules to joules. So that means we have 40,700 joules. And then I'll put the moles down here. And then we have 8.315. And then we'll have joules, mole, Kelvin up top. All right, so then these joules cancel out and these moles as well. We have 1 over, which one did we say was T2? Well, we're going to work with 373 minus 1 over 363. Okay, so now that we've actually filled in our equation, it's straight calculator work. So as long as we can plug everything into our calculator correctly and properly, we should get to the correct answer. So everything over here on the right should give us negative 0.3615. And that's again equal to ln of P1. Now, for those of you that don't remember, when we need to cancel out an ln, we can't just divide both sides by ln. We have to actually use our e. We have to exponentiate both sides. So now P1 is equal to e to the negative 0.3615, and that is equal to 0.697. And again, because we initially used ATM over here in the when we plugged in, our answer will also be in the same units. So we have ATM. All right, cool. Let's get into the next problem. So this one reads, the vapor pressure of ice at 268 degrees Kelvin and 273 degrees Kelvin are 2.965 and 4.560 torr respectively. Estimate the heat of sublimation of ice. So here we're given two pressures, two temperatures, and of course we have R. So what we're solving for is our delta H. So now let's go straight back into our plug and chug. So we have ln. I'll call this one right here. Again, goes with this one. And then these two go together as well. I'll call the 4.560 our P1. And this our T1, this our P2, this our T2. Okay, cool. So as long as we get the two that belong together are plugged in the right places, we should be fine. This is an important step before we start the problem. All right, so let's just plug and chug. We get 4.560 over 2.965. That's equivalent to, again, we don't know this, so I'll just use the term x over 8.315. And then we're going to put 1 over 268 minus 1 over 273. All right, so if we divide that out and we ln it, we should get 0.430 on the left, and we should get 0.00000, so 5 zeros, 821x. So then we're just going to divide both sides by this really annoying number. And our x is equal to 52,318. And again, because we're solving for delta H, it's always going to be in joules per mole. So we have it here in joules per mole. And that's our second answer. So again, as long as you plug these in the right spots in the equation, the rest is just straight calculator work. If you're still confused on these topics, feel free to comment down below or come to SI office hours, and have a good day.